Good evening, agents. This is the director. I'm calling today for a critical briefing regarding our ongoing infiltration of Boeing. Boeing is mostly known for their aircraft manufacturing. They've built nearly half of all commercial aircraft worldwide, and roughly 90% of all air cargo is carried on Boeing planes. Boeing has several major competitors, including Airbus, Lockheed Martin, and Gulfstream. As you know, Boeing isn't just an aircraft manufacturer. They are one of NASA's most strategic partners with access to advanced aerospace technology, classified spaceflight data, and cutting edge engineering projects. Our objective is to gather intelligence on their collaboration with NASA, particularly anything regarding their space launch systems. We know that the target has designed the SLS to carry heavy items into space. We also know that this advanced technology was used in the Artemis mission. We further know that Boeing uses the Azure DevOps as a critical tool in their SLS production. This tool is used to streamline daily operations by automating information between systems. The Azure DevOps tool, or ADO for short, uploads information into the SAP manufacturing execution system and will allow managers to plan and monitor work queues. Boeing's ongoing operational costs are low due to their use of a highly automated system. However, startup costs are high and require significant investment. The intelligence you all gather from Boeing's collaboration with NASA will be critical in our future success. Every detail matters, and we must know everything they are keeping behind closed doors. I look forward to your reports.
This is Agent Rocket Booster with mission SAP. This is highly classified, and because of your top secret clearance, I'm able to share certain components of this mission with you. Right now, NASA is trying to go back to the moon. They want to put a space station on the moon. This is a very complex mission called Artemis 4, highly classified. We are exploring the companies that are making this possible right now. There are many companies that are involved in building the components and assembly of this rocket. In particular, today, we're going to talk about Boeing. Boeing is making 3 huge components for this. I have to make sure that I get this done quickly because they're after me. First of all, they're making the core stage. The core stage is the central part of the rocket. It is 200 feet tall. It is powered by liquid oxygen and hydrogen. This massive payload that's going to take to actually get all the components up to the moon is going to be a bigger rocket than we've ever had before. So it's going to have to store more fuel to power the engines to actually get it up off the ground and into orbit. The exploration upper stage will take over as soon as the core stage is released from the rocket and the spacecraft is orbiting around the Earth. This EUS is going to be able to power the rocket to break free of Earth's gravity and continue on its way to the moon. The EUS is also powered by liquid oxygen and hydrogen for its fuel. The third main component that Boeing is making is the avionics. This is the most complex mission with the most power and payload that we have ever had. So the avionics, which is simply the computer of the system and the navigation, is the most complex hardware and software that has ever been designed. When will this mission happen? This mission is supposed to take place as early as 2028. But with the complexity of many companies having to make components for this rocket in this top secret manner, it could have delays, but it is happening. Agent Rocket Booster, out.
Yeah, I'll be sure to get those reports to you by lunch. All right, have a good day. Talk to you later. All right, team. I'm here in my office with Boeing SLS in New Orleans, and today I want to talk to you about the systems we use to make our systems better and optimize throughout a daily cadence that can help us tremendously. So the first system I want to talk about is SAP MES, which is our manufacturing execution system. The system allows for quality control and many different other items such as paperless operations. But to get there, we need to work within the MES production system, which is where a team of manufacturing engineering planners will go into to write the work instructions. Those work instructions will then go to a sign-off cycle to approvers, quality, and customer. Once those work instructions are verified, they then get produced as work orders into our shop floor maintenance. Their production operations and the floor technicians will use those work orders to execute the plan to build our product. However, what this system does not allow us to do is communicate vastly across different organizations to set daily goals and priorities to make sure that these tasks can be carried out with every team knowing what we want to execute in that day. So what we do is we export that data every night into a repository. We then use Observe DevOps or ADO that we've custom built APIs to pull the data specifically that we need into ADO, and each morning it allows every manager across all organizations to verify our daily goals of what we want to build that day on our product, and then it allows cross communication to allow each team to know what we want to do. It's very organized because it allows you to produce queries, different dashboards, and different boards. And with that data, it also allows managers on a weekly or bi-weekly cadence to do metrics to see how the team's performing to plan. With these systems, our company has saved a tremendous amount of time within this past year and money by implementing these systems. It reduced headcount of a team of 12 to 10 managers on a daily basis across organizations into a team of 2 every morning, executing the plan and getting the data out across our organization. I hope this helps, team.
Hi team, I'm Agent Last Course. I completed my surveillance on Boeing's production engineering operations for NASA's Space Launch System, which we refer to as SLS. I've gathered enough intel to map out exactly how they're running their planning process using the SAP Manufacturing Execution System and the Azure Development Ops. And all this information is here in my top secret classified folder. Today, I'm going to walk us through the business process my team focuses on and how the information system ties into it. We're looking at Boeing's production engineering organization that supports NASA's Space Launch System. As mentioned earlier, Boeing is a global aerospace company that designs and builds commercial airplanes, defense systems, and space hardware for customers. Within that big picture, our slice of the team in New Orleans. This team plans the work instructions for the SLS core stage and the exploration upper stage. Our focal business process is planning, approving, and releasing the detailed manufacturing work instructions that tell the factory exactly how to build SLS hardware step by step. Looking at a high level, here's how that process works. It starts with a trigger, maybe a new piece of hardware for the core stage, a change to the exploration upper stage design, or a schedule update coming from the SLS program. From there, a manufacturing engineer then updates the work instructions in the MES system. Once that draft plan exists, it moves through a sequence of workflow states like planning, quality review, and approval. Different roles work on each step, and they're responsible for checking accuracy, that it complies with NASA standards, and aligns to the production schedule. When that plan is fully approved, it is released to the shop floor and becomes the official set of instructions that the technicians follow on SLS hardware. As Jack mentioned, this isn't a one and done process. It is part of a daily system for the program. Every night, ADO pulls the latest planning status from SAP. This update takes about 1 to 2 hours every day. And by the time people walk in the next morning, the board and queues in ADO already reflect where the plan sits, whether that's in planning still, waiting on approval, quality, and so on. So throughout the day, managers and engineers use these queues to set priorities, balance workload, and make sure the right tasks are moving first to support the hardware that's coming through the line. At the end of each week, the same data is aggregated into performance dashboards, things like backlog size, cycle time, and agent work instruction. So leaders can look at these trends instead of just fighting fires day to day. So the business process isn't just creating individual work instruction, it's also creating a continuously planning and monitoring loop that supports SLS production every single day. For this process to really work, there are a few things that absolutely have to go right. First, data accuracy. The information coming from the MES has to be correct. Operations, materials, and routing, and so on. Because the whole point is to analyze and act on the data quickly. Second, a stable digital thread. MES exports into a repository and then into ADO. This continuous flow of data is what keeps the planning boards meaningful. Even if something interrupts the automatic flow, the process is designed so that the data can be exported and restored, keeping the thread intact. Thirdly, timely updates and filters. Predetermined filters in ADO and in the scripts help sort, clean, and structure the data so planners don't have to start from scratch every morning. Regular updates to those scripts based on user feedback keep the experience smooth for managers and end users who are actually setting priority. Strategically, all of this supports Boeing's mission of connecting, protecting, exploring our world and beyond. When the process works well, it reduces rework, supports first-time quality, and helps ensure the SLS stages are ready when NASA needs it. Overall, the information systems don't just document the process, they reshape how the teams work day to day. ADO replaces a patchwork of trackers and email chains with a single shared view of work. That alone has driven down manual labor and saved the order of 10 to 15 hours of engineering time per day, just from automation and centralized data. For managers, the overnight update and dashboard mean that they start their day with a prioritized view of planning work instead of spending their first hour just trying to figure out status for the program as well as a whole. The digital thread between MES, ADO, and Power BI creates a better program level oversight and supports decisions that keep SLS on schedule for its missions.
Talk to you about the benefits and drawbacks of Boeing. So we'll start with some of the benefits. Um, the first thing that we found is that automation reduces manual data entry and Excel maintenance. One of the shared system replaces many local trackers. With Boeing, the dashboards reveals bottlenecks in planning, approval, and quality, and web-based access supports cross-site collaboration. Another benefit that we found really helpful was that weekly performance reviews use common metrics from ADO data. Now, even though benefits are always a good thing, we did find that there were some drawbacks. Some of the drawbacks included technical issues, which could consist of data transfer bugs, which also creates duplicate line items. Another technical issue that we found was that incorrect calculation of production need and priority dates would happen a lot. State changes, overwritten assignees. A lot. And then also, when we spoke to Jack, he did state that plans sent back for rework would not auto assign from the previous owner, which caused confusion in ownership and personal communication. And we spoke to him on like sometime last month, November of last month, early mid November. Another drawback that we found was that reporting and analytic constraints. The ADO charts and pivots were useful for quick views, and the Power BI preferred for detailed metrics and presentations to senior leadership. Now, the third drawback that we had was that ongoing evolution with the core ADO solution remained stable. The user interface and features are constantly updated based on user feedback. And then, last but not least, dedicated support structure was our fourth drawback. And with the dedicated support structure, it was provider side support teams and Boeing focals and small developer team managing and enhancing ADOs with the dedicated support structure. So definitely some good points with the benefits, but definitely there were some drawbacks as well that we found during our investigation.
Agent North reporting, Mission Upstream Supply Chain, Recon Boeing Operations. 2. Director, Strategic Intelligence Division. Director, this is Agent North. Submitted my upstream supply chain assessment for Boeing's operations. My mission was to analyze how Boeing acquires raw and semi-finished materials and how those upstream systems influence overall production. Boeing relies on a large and diversified supplier network. This is intentional because in aerospace manufacturing, depending on a single supplier for any critical component is a major risk. Let me check my notes. This diversity is essential if Boeing relied on only one engine supplier and that supplier stopped production, Boeing's entire manufacturing line would come to a halt. Their supplier diversity program ensures that no single vendor becomes a production bottleneck. Once these materials and components are secured, they move into Boeing's assembly plants. But upstream forecasting is where complexity intensifies. Upstream suppliers must prepare long in advance for forecasting. Forecasting becomes even more challenging because Boeing's infrastructure is massive. If demand for a newly launched aircraft is higher than expected, upstream systems struggle to expand quickly enough to support increased volume. Director, this concludes my report. Upstream systems analyzed. Supplier stability confirmed. Agent North, report complete.
Director, this is Agent Cascade delivering my official assessment of the downstream supply chain for Boeing's operations. My objective was to decode the downstream processes where upstream materials are transformed into fully integrated aircraft and mission-ready systems. Once upstream materials move into production, they enter Boeing's large-scale assembly environments. The most significant of these is the Boeing Everett plant. Nearly 100 acres in size and 472 million cubic feet in volume. It is the largest building in the United States. It serves as the core facility for assembling Boeing's largest commercial aircraft. Downstream processes demand precise coordination. A single commercial aircraft requires 18 to 36 months to assemble, involving thousands of components and millions of individual steps. Any disruption in timing, system communication, or workflow can cascade across the entire production schedule. Once aircraft are completed, Boeing generally leases them to major airlines such as American Airlines and Southwest. By contrast, manufacturers like Gulfstream typically sell their jets outright. This mixed model complicates downstream forecasting and requires constant adjustment to production timelines. Forecasting remains one of Boeing's most challenging downstream tasks. When a new aircraft is announced, demand often spikes instantly. However, expanding production capacity to meet that demand is difficult. Boeing's infrastructure, especially the Everett plant, cannot scale quickly or inexpensively. If demand outpaces capacity, lead times increase and delivery schedules shift significantly. Boeing's downstream strategy currently centers on two priorities. First, quality. After the grounding of the 737 MAX, Boeing has strengthened quality protocols throughout downstream operations to rebuild public confidence and reinforce product reliability. Second, innovation. Boeing is developing a small electric personal aircraft, including a vertical takeoff prototype that eliminates the need for a runway. This advancement will require new downstream production methods and integration systems. This concludes my report. Downstream systems assessed, production flow confirmed, Agent Cascade out.